James Webb Space Telescope findings inside Betelgeuse, the giant star that blew its top, and what it means for the future of the universe. Remember late 2019, when the Orion constellation looked strangely dim? You weren't imagining it. That wasn't just your eyes playing tricks. The culprit was Betelgeuse, the red giant that suddenly dimmed so drastically people across the world began asking, is it about to explode? Astronomers scrambled. Headlines screamed about a possible supernova. And then, silence. But now, thanks to the James Webb Space Telescope, JWST, we finally know what really happened. And the truth is even more mind-blowing than the rumors. Betelgeuse, the star that refused to behave. Betelgeuse isn't just any star. It's a red supergiant, more than 700 times the Sun's diameter, located about 650 light-years from Earth. It's one of the brightest stars in the night sky, but its behavior in recent years has defied everything we thought we knew. This isn't just a story about astronomy. This is about the chaotic heart of the cosmos itself. When the Great Dimming happened in 2019 to 2020, it set off alarms. Was Betelgeuse entering its death throes? Were we witnessing the prelude to a supernova that could briefly shine brighter than the full moon? JWST launched just in time to dig deeper, and what it found has stunned even the most seasoned scientists. The star that blew its top, literally. Let's be clear, Betelgeuse didn't just hiccup, it exploded from within. The James Webb Space Telescope confirmed what Hubble had hinted at, a massive surface mass ejection. Not just a flare, not just a puff of gas. Betelgeuse ripped off part of its surface and hurled it into space. This wasn't a solar flare on steroids. It was 400 billion times more powerful than our sun's typical outbursts. That's like comparing a matchstick to a thermonuclear bomb. The ejected mass weighed several times more than the moon. The explosion blocked about 25% of Betelgeuse's visible surface. The expelled dust formed a giant cloud that temporarily made the star fade in Earth's skies. For astronomers, this was a once-in-a-generation event. And JWST, it captured every smoky, violent detail. What Webb found deep inside the giant. Armed with cutting-edge instruments like NIR Spec and MIRI, JWST didn't stop at the surface. It peeled back the layers of Betelgeuse's atmosphere, revealing its chemical fingerprints, carbon, nitrogen, oxygen, and how they swirl and erupt through its layers. But it went deeper still. By examining infrared emissions and pulsation patterns, JWST allowed scientists to analyze the star's mass loss rate, critical to understanding how stars die, map surface hotspots, convection currents, and plumes of boiling gas, study internal structures that hint at how close Betelgeuse is to its final act. This wasn't just data, it was an autopsy report on a living star, and what it revealed could rewrite the textbooks on how supernovae actually begin. For scientists, Betelgeuse has always held a special place in the cosmos. But now, it's more than just a red dot in the sky. It's a living, heaving, unstable monster, undergoing one of the most violent changes ever witnessed in a normal star. Imagine the emotional whiplash. First, the excitement, It's dimming. It's going supernova. Then, the letdown. No, it's not exploding. Yet. Now, the awe. It ejected part of its surface. That's never been seen before. This is science as a roller coaster. And JWST is the front row seat. Is Betelgeuse about to blow? Not yet. But despite the drama, Betelgeuse isn't going supernova tomorrow or even next century. Most models suggest it still has about 100,000 years to go before its final collapse. But now we know, even long before the end, stars like Betelgeuse can erupt violently. These pre-supernova events may be key indicators of what's to come, and JWST is watching closely. In the meantime, scientists are using JWST's data to recalibrate supernova prediction models, mapping out the final centuries or millennia of massive stars like never before. What if Betelgeuse isn't the exception, but the beginning of a new rule? Its wild behavior challenges every clean, step-by-step model of stellar death we've built. Stars don't just age gracefully. They rage, rupture, and remake their surroundings. This discovery suggests a phase of stellar evolution that's far more violent than previously thought. Betelgeuse's outburst may be the cosmic equivalent of a massive heart attack, a warning sign, not the end itself. And this brings us to a haunting thought. How many other massive stars out there are also hiding similar tempests, waiting to erupt? We're witnessing a new chapter in astronomy. JWST's findings aren't just interesting, they're urgent. Supernova precursors could now be identified earlier. We might one day predict stellar explosions the way we track hurricanes. And if Betelgeuse does blow in our lifetime, it'll be visible in daylight for weeks, and it won't harm us. But the cultural and scientific impact would be seismic. There's no time to waste. The universe isn't waiting. Who's watching? Everyone. Even the most skeptical astronomers are riveted. Across NASA, ESA, CSA, and beyond, Betelgeuse has become the poster star for high-risk, high-reward astronomy. It's the ultimate case study in cosmic volatility, and the James Webb Space Telescope is the world's most powerful tool for studying it. From astrophysics departments to backyard stargazers, Betelgeuse has united a world of minds with one question: what is this star trying to tell us? Wait, what about the studies saying it could explode sooner? Good question. There have been a few studies and some high-profile YouTube videos that argue Betelgeuse could be further along in its evolution than previously believed. Some models suggest it might go supernova in just a few hundred years. But here's the kicker: these views are far from mainstream. The issue lies in the uncertainty surrounding the star's outer layers. Betelgeuse is what scientists call a fluffy star. It's huge, puffy, and unstable. Measuring its exact size, mass, or core fusion status is like trying to guess someone's heartbeat from across a stormy lake. The data is noisy, and interpretations vary. So, while the idea of an early supernova is fun to speculate about, the scientific consensus still says we have plenty of time. What does NASA and JWST actually say? This is where things get crystal clear. NASA has not issued any statements suggesting that Betelgeuse is about to explode. Neither has the ESA, CSA, or any major observatory involved in JWST's mission. JWST's advanced instruments, like IR-SPEC and MIRI, have allowed scientists to capture detailed spectra of Betelgeuse's atmosphere, revealing its chemical composition, structure, and recent changes. This helps us understand why it dimmed, not that it's dying. The result? Continued monitoring, not panic. There's no hidden alert, no secret timeline, and no evidence of any cosmic disaster countdown. Betelgeuse is being studied closely because it's unpredictable, not because it's about to blow. Why the rumors keep coming back? Let's face it, the idea of a visible supernova in our lifetime is irresistible. Imagine looking up into the sky and seeing a second sun, a beacon so bright it casts shadows at night. Betelgeuse is a prime candidate for that kind of show. So when anything out of the ordinary happens to the star, like dimming, pulsation shifts, or size fluctuations, the headlines write themselves. But we must separate dreams from data. If you've seen sensational videos or posts claiming JWST has confirmed the explosion is near, they are not based on verified science. They're exploiting our curiosity, our craving for cosmic drama. The fear. Could Betelgeuse hurt us? Let's address the big question. Are we safe? This is where logic triumphs over fear, and facts chase away the fog of rumor. Too far to harm us. Betelgeuse is about 640 to 650 light-years away. For a supernova to pose any serious risk to Earth's biosphere, whether from gamma rays or shock waves, it would need to be within 160 light-years. Betelgeuse is 4 times farther away. That alone guarantees our safety. Radiation would dissipate. The radiation from such an explosion would be mostly harmless by the time it reached Earth. No mass extinction, no geomagnetic havoc, just light, a beautiful, awe-inspiring burst in the night sky. Sky spectacle, not doom. When Betelgeuse finally does go supernova, it will outshine the full moon for weeks. You'll see it during the day. At night, it will glow like a second sun. But it will not bring catastrophe. It will bring a once-in-a-civilization astronomical event. Let's take a step back and feel the poetry here. Betelgeuse isn't just a star. It's a living reminder of the vastness and violence of the cosmos. It's dying, yes, but in its death throes, it is teaching us about life, cycles, and resilience. Imagine it. A star, more than 700 times the diameter of our sun, releasing its outer layers in a desperate gasp that reaches across centuries of light years to finally touch our eyes in 2025. This isn't just science, it's a story of cosmic aging, of explosive drama, of survival through chaos. Betelgeuse dimmed. We panicked, then we learned, and now we marvel. What the experts say. This isn't just guesswork or sci-fi chatter. Leading voices in astrophysics have echoed the findings. NASA scientists emphasize that the dimming event was traumatic, but not terminal. Sky and Telescope magazine reassures us Betelgeuse's future supernova is a gift to skywatchers, not a threat. Phys.org notes that models place the explosion thousands, perhaps tens of thousands of years away. EarthSky, a respected astronomy outlet, adds, we'll be safe, but we'll have front row seats to one of the greatest shows in the sky. These aren't fringe theories. They are the consensus of our best minds. Betelgeuse is dramatic, but not deadly. Maybe you're not an astronomer. Maybe you just like stargazing. Or maybe you've never thought much about the cosmos. But this story matters, because Betelgeuse is our reminder that we are part of something grand and ancient. Because it shows how science can quiet fear with clarity. Because it proves that truth is more beautiful than the rumors. And because when Betelgeuse does go supernova, whether it's tomorrow or in 10,000 years, you'll remember this. You'll look up at the sky and say, I knew this was coming. I understand it, and it's breathtaking. So, what comes next? JWST will continue watching. So will other observatories, ground-based and orbital. The data will keep flowing, and so will our understanding. More surface changes? Possible. Unexpected pulsations? Likely. Another dimming event? Maybe. But danger. Number. The real danger is missing the beauty, the science, the unfolding drama that Betelgeuse offers us. The danger is turning our eyes away because of unfounded fear. What makes this event unique? 1. Unprecedented scale. This surface mass ejection is unlike anything previously seen in stellar astronomy. The sheer size and weight of the expelled matter dwarfs any known stellar event outside a supernova. This was not some localized flare. It was an atmospheric rupture on a galactic scale. Second surface disruption. Where other stars lose gas from their outer layers, Betelgeuse lost actual parts of its visible surface. That's like watching Earth erupt and fling chunks of its crust into orbit. Not just volcanic ash, but entire land masses. 3. Lasting instability. Years after the event, Betelgeuse is still not back to normal. Its internal rhythms, brightness cycles, and energy output are erratic. JWST and other observatories are monitoring the ongoing bounce in its interior, which no one yet understands. Urgency and scarcity, a one-time glimpse into a rare stellar phase. This may be a once-in-a-century event. Astronomers have speculated that Betelgeuse, a red supergiant nearing the end of its life, could eventually explode in a Type II supernova. But no one expected to catch it in such a dramatic act of upheaval before the final blast. JWST's timing couldn't have been better. It launched just in time to witness one of the rarest known phases of stellar evolution, capturing it in extreme detail before the cosmic dust literally settles. This is the kind of data astrophysicists dream of, and often miss by centuries. We are now watching the slow-motion recovery of a red supergiant that tore itself open before our eyes. The expelled surface is still cooling and dispersing into space. The star is still healing, still rebalancing, still echoing with the aftermath of its own internal storm. But this isn't just Betelgeuse's story. It's our story too, a testament to what happens when we build instruments like JWST, when we reach beyond Earth, and when we listen to the whispers of the stars. The James Webb Space Telescope has given us more than just data. It's given us a front-row seat to stellar evolution in real time. You've seen the journey. You've felt the awe. Now make it part of your own curiosity. Keep watching Betelgeuse, because the next chapter could shake the cosmos even more.